Hi everybody, welcome to Mrs. John's lesson, and this is a video meant for the lesson on Tuesday the 2nd of March. And what we're doing in this lesson is basically completing these diagrams on the force diagrams. So we did in class on Friday, we actually figured out whether the forces were balanced or unbalanced, and as a result we also wrote down whether there was no motion at all, that means was it stopped, or if it was moving, was it going at constant speed in a straight line, or if the forces were unbalanced, then it would be accelerating in the direction of the unbalanced force. So what your task was to actually, and what we were going to do is draw these diagrams, and this is what these force diagrams look like. So when we draw a force diagram, we just draw the object as a box. So for example, for the first one, where you are standing on a horizontal floor, so there's your floor, and you, the person, you just draw a box that represents you, and there are two forces acting. So there is your weight force pushing on the ground, and there's a reaction force equal and opposite from the ground. There are two ways of drawing the weight force. One, you can start from the bottom of the box, or you could start from the middle of the box, because the mass of an object is concentrated at point where the object will balance. It's called the center of mass, but you can draw it this way. And the reaction force is from the ground, so you're actually drawing an equal and opposite arrow from the ground. So this is your reaction force. Okay, a car parked on a road, so similar. So this was 1 and this is 5, about the car parked on a road. So this is your road, this is your car. Two ways that you can draw it. You can draw your weight force from the bottom. So there's your weight force because it's on the ground. And then the reaction force from the ground, you can either draw it from the top of the box, or you could ideally draw it from the ground up. So there are a couple of ways of doing the same thing, and they're both accepted. Okay, and you try and work your way through that, and I will take a photo of this and put the answers up. So that's your first task for Tuesday. And then when you finish that, the other thing that we are going to learn about in today's lesson is about mass and weight. What is the difference? So colloquially, you ask for somebody's weight and they tell it you in kilograms, but that's not quite right. So I'll just rub the board over here. So we're going to look at mass and weight. So we've looked at force diagrams. Mass and weight. Now, mass is the quantity of matter in a body, how much of the substance there is, and mass is measured in kilograms, and the letter to represent mass is the letter M, and it's measured in kilograms. And because it's a quantity of matter in a body, the mass does not change when you go from one place to the other. When I'm saying one place to the other, if I went from the earth to the moon, I'll still be the same mass. All of me would still be there. Okay? Or if I went to Jupiter, then I would still, my mass would be the same, and whatever kilograms it is. Okay? Weight, on the other hand, is a force. It's a force exerted by gravity pulling the object down to the center of the earth. So that's a force, mass is not. And the symbol for weight is Fw, so that's the weight force, and it's the pull of gravity on the object. And the way we calculate weight force is m times g. So if somebody's mass was 50 grams, and the value of g, which is the acceleration due to gravity, the force with which the earth pulls everything towards itself, is 10 newtons for every kilogram of mass. So it's 50 times 10, which is 500 newtons. So that's the weight force, and the mass will only be 50 kilograms. Okay? Now, the weight of the object, it tells you like if you're feeling heavy or light. It all depends on this value of g, which is the acceleration due to gravity. So if you went to the moon where the force of gravity was much less, and the reason why the force of gravity is much less on the moon is because the moon is much smaller compared to the earth. So the gravitational pull of the moon is not as much as it is of the Earth. So in fact, the gravitational pull of the moon is only 1.6 newtons for every kilograms. So you would feel much lighter if you went to the moon. And so your weight, if you went to the moon, and if let's say somebody is 50 kilograms, it's 50 times 1.6. Okay, so that's as much as it is. So that's 50 plus 30, that's about 80, maybe about 80 kilograms. I've just done it in my head. Um, but but your weight force on Earth would be 500 newtons. So 80 newtons as opposed to 500. So it's the weight that changes from place to place. Now, this whole thing about this force of gravity, anything that has mass has this gravitational force pulling everything else towards itself. Now we have mass, and you think like, why aren't we like bumping into each other and pulling everything like running towards us? The reason is the size of this gravitational force is proportional to the mass. So that means the more massive you are, the greater this pull, this gravitational pull. And our masses are really small. It's insignificant compared to enormous masses like the mass of the Earth or the Sun or the Moon. Those are the ones that really have an effect. Okay, so that is, and if you had just listened to this video a second time, you will be able to answer all these questions on what is weight. So try and answer that. And once you've answered that, I will upload a photo of these answers that I've written for you to cross-check your answers. Okay, so that's our lesson for today. So it's about completing force diagrams and getting an idea of what is the difference between mass and weight. Copy notes, and there are 2 worksheets that have to be done. So bye for now.